Hello again. So this is the second video covering some past material back from Module 5. So this once again is solving systems of equations, but this time using an elimination method. Last time we were doing the substitution method. So this process is a little bit different, but the end result is we're still finding the location where the two lines intersect. The idea behind this is to eliminate one of the variables, either the x or the y. And the way we were learning how to do this is by subtracting the equations. So we have two different systems of equations, the one on the left and the one on the right, and we're going to start with the one on the left. And we're going to subtract these two equations. What makes these two equations so nice to subtract is the fact that we have a positive 2y here and a negative 2y in the second equation. What makes that so nice is that when we add those equations, they will add to 0. 2y plus negative 2y adds to 0. And so if we add these equations, we can see that the y values will eliminate. So 3x plus negative x is 2x. 2y plus negative 2y is 0y, and negative 5 plus 3 is negative 2. From here now we solve for x. 0y is just 0, and so it's 2x equals negative 2, and we divide by 2, so x will equal negative 1. Once I know the value of negative x, I can use that to find the value of y. And in this case, I'm going to use the second equation, mainly because it looks like it's a little bit easier to solve. But you could use either one. And so I'm going to rewrite the second equation. Negative x minus 2y equals 3. And so since negative x equals negative 1, I'm going to make a replacement in here for x. And so it would be negative, and then in parentheses, negative 1 would preserve our signs. So I'm replacing the x with a negative 1 minus 2y equals 3. The negative of negative 1 is positive 1 minus 2y equals 3. So now I'm going to solve for y and subtract 1 from both sides. So negative 2y equals 2. Divide by negative 2. And y equals negative 1. So my solution happens to be the ordered pair of negative 1, negative 1. We could have thought of this problem in another way besides adding. We could have thought of it in terms of subtracting. So if we think of it in terms of subtracting, the problem would look a little different. And I'm going to show you that. So I'm going to take the original equations. 3x plus 2y equals negative 5, and negative x minus 2y equals 3. So if we wanted to subtract these equations, right now if we start to subtract them, 2y and negative 2y don't subtract to 0. But what we can do is take one of these equations, either one, and multiply it by a scale factor to make it so that we can subtract to 0. A nice thing when we're trying to subtract a number, any two number to equal 0, it's always the same number. So if it was 7, it's always these two numbers here, always the same. So if I want to get the y's to be 0, I need to make the 2y and the negative 2y to be the same. And one easy way to do that is to take this bottom equation here and to multiply the whole thing by negative 1. So I multiply this whole equation by negative 1. The new equation would be x plus 2y equals negative 3. And from here, we can still do the same process, but instead of up here where we're adding, we're now going to be subtracting. So I'm going to rewrite the equations down here. So I have these two equations. I'm going to rewrite them down here. So we have 3x plus 2y equals -5, and x plus 2y equals -3. I'll redraw this arrow. And now instead of adding, we're going to subtract these equations. And it's important that we're subtracting. So 3x minus 1x would be 2x. 2y minus 2y is equal to 0y. And here, -5 minus -3. So we got to be careful there. -5 minus -3. That's the same thing as -5 plus 3, which is -2. So it's -2. So now we're here again, and if you look, this, oops, let me use this equation is the same as the one we got here when we added. So we'd be at the same result, we'd still get the same answer. So we're going to use this idea of subtracting on the second problem that I have over here. So we're going to try to subtract these equations. If we subtract these equations, -x, 5x, 2y, and 3y, those are not going to give us 0 if we subtract. That's a problem. So we have a couple options. We can multiply. And so I'm going to choose to try to eliminate the x. So I'm going to multiply this top equation so that it would eliminate this 5x by subtraction. So I want this to be also 5x. So to do that, I have to multiply this -x by 5, but also by -5, so that these two values are exactly the same. So I'm going to multiply this top equation by -5. And I'm going to put my solution right underneath it. So -5 times -x would be 5x. -5 times 2y would be -10y. And -3 times -5, a negative times a negative is a positive, so that would be positive 15. And so now I'm going to take these two equations and I'm going to subtract these equations. So 5x minus 5x is 0x. -10y minus -3y. We've got to be careful there. Do it over here. -10y minus -3y. Well, that's the same thing as -10 plus 3y. Oops. -10y plus 3y. And that is -7y. And then we have 15 minus 1, which would be 14. So then from there we can solve it. We can eliminate that. 0x is just 0. We can disregard it. So now we have -7y equal to 14. I'm going to divide by -7. So y would equal -2. I know y is equal to -2, which is good. And now I got to use another equation. Now I can use any of these equations, and I'm going to choose to use this first original equation up there, mainly because it's the one with the least number of multipliers to y. So -x plus 2y equals -3. So I know that y is equal to -2. So -x plus 2, and in parentheses we want to preserve our signs. Y is equal to -2, so plug that in. Minus equals -3. So now I'm going to solve for x by combining like terms and distributing. So x plus 2 times -2, which is -4, equals -3. I'm going to add 4 to both sides. So -x equals 1. If -x equals 1, that means that x equals -1. So my solution is going to be negative 1, negative 2.